Hi everyone, welcome back to our MMAT assignment. This is video 2 of 6, Basic Static Analysis. This assignment is done by Ian, Hansel, and myself, Matilda. So today we'll be doing basic static analysis. First and foremost, we'll be analyzing the malware with VirusTotal. Then we'll be looking at PID to detect common packers and compilers of a PE file. Then we'll be looking at WinMD5 to generate the hash of the malware. Next, we'll be looking at PEView that would provide the function to view the structure and contents of a PE file. Next, we will be looking at Dependency Walker, which is used to list out all export and import functions of the PE file. Last but not least, we will be looking at bintext.exe to scan and extract for strings that are hidden in a PE file. So let's get started with VirusTotal. Over here I have the malware loaded already and I'll be scanning it. So view last scan. So the detection ratio is actually 52 out of 58 antiviruses, and there are a lot of feedback saying that it's an identified malware. So it's probably a malicious malware, already an identified malicious malware. But let's take a look at it anyways. We even have names backdoor/irc.sdbot.05.p McAfee. So let's get started with our static analysis in Microsoft XP. Over here, I have all the tools installed already and ready to go. So let's get started. First and foremost, we would actually be looking at the unpacking. I have the malware over here, and I'll be dragging it in. So based on the results indicated, this malware is not packed because it's LCC, which actually represents local C compiler. So LCC is a program compiler, much like Microsoft C. So this suggests that the file is most likely unpacked. We also have an extension of .text, so this indicates that the file has a high chance of being in plain text, such as Notepad, rather than being an obfuscated file. So we now know that the malware is not packed. Moving on, let's take a look at the MD5 of the malware. So MD5s are used to it's actually important to check the hash of a malware, as the process of hashing is irreversible. So this means the hash is unique and can be used to verify a file's integrity. So over here we have the file's hash. We might need it later for identification purposes, but for now it's good to know, and it's good to check with the place where you have downloaded your malware to check that it's the same MD5. Next, we will be looking at PEView. So PEView actually displays intricate information about the malware, and it shows the date of compilation. So let's load the malware in, and under image file header, it's over here. So the compilation date is 2002 05/17 Friday. So moving on, let's take a look at Dependency Walker, which will be giving us a brief of DLLs and APIs that are called in this malware. Loading the malware in. Let's expand this. So we actually see around 6 DLLs. We have sock32.dll, which is Windows socket 32-bit DLL. We have Internet extension for Win32. We have shell, Windows shell common DLL. We also have Windows NT-based API client DLL. Advanced Windows 32-based API. And last but not least, Microsoft C runtime library. So let's take a look at the imported API functions. So first and foremost, let's take a look at wsock32.dll. So the first thing we see is WSA cleanup and WSA startup. And these two functions terminates and initiates the use of WinSockDLL. If we just scroll down, we also notice that there's a socket. So it creates a socket that is bound to a specific transport service provider. So WSOCK32.dll is essential for TCP connections. Moving on, let's take a look at WinINet.dll. It actually has HTTP request and sending internet connect, internet open. So HTTP send request, for example, closes a single internet handle, and HTTP send request actually sends a specified request to the HTTP server, and internet close handle actually closes a single internet handle. So these are also used for internet connectivity. Next up, let's take a look deeper into WinINet.dll. There are a lot more DLLs that are actually called. We can take a look at kernel32.dll, and we can actually take a look at create file. But create mutex is what really intrigues us over here, because it actually creates or opens a named or unnamed mutex object, and we all know that mutex is quite a clear, it's relatively a higher indication of malwares to run threads more concurrently. Next up, we can also take a look at advapi.32.dll. So we can just scroll down and we see all the registries APIs functions over here. So for example, ret create key XA actually creates specified registry key. However, if it exists, the function will open it. So this function is used to either create or open up A. So we know that this malware also has something to do with registry. Moving on, we look at normalise. Okay, let's skip that, because if we open up normalise, it actually looks pretty okay. So we can actually also take a look at shell32. We can take a look at the DLLs inside. There is a lot more DLL. So there's an interesting one, MSI over here. If we just open it up, and we also have ODBC and then kernel. Let's open this up a little bit more. So we also have creating mutex already. We actually see create mutex. So definitely something to do with mutex. Open mutex. So interesting. Next up, let's take a look at the main parent DLLs. Kernel. So copy file, create process, create thread. Important. We also see sleep and terminate thread write file. So sleep is actually to suspend the current process until the time limit is set. We take a look at advapi.32.dll. We see all the registries. So handle to specify the specified registry key. So these are functionalities to do with registry. So we know that this malware also has something to do with registry, as mentioned beforehand. Last but not least, let's take a look at the Microsoft C library. We have a lot of strings, like, for example, strcat, append or change one string with another. We also have signal, which actually identifies the position in the workspace, and then send the application an _MCI signal message. So we have evaluated this. Let's take a look at bin tags. So I'm going to load the malware in again. Going to expand it. So the first thing that we see is very interesting already. We already have a URL. We have a hashtag gone away, Win32, so internet. Another URL, another hashtag, another gone away. And then we have an executable over here, and a configuration loader. So maybe these are things that we need to take note of later. So until from here onwards, it looks pretty important already. Moving on, we see some kind of condition going on here. A lot of string messages. We also have IP address, so connection type local IP address, which is probably some kind of argument connected from some kind of port or so. So we see some kind of action going on over here. Someone has quit, someone has left, someone has joined. This sounds like a chat, so this is probably botnet. Nick is already in use, so users in spy is created on something in channel. We have ping, downloading. So these all just look like strings, very interesting strings. Removing bot, cjoin, cnic. So these looks like actions. Moving on, we also have sdbot. So we have some sort of email list over here. sdbot 0.5 ready. User logout. Then we have some sort of, I think I saw it just now. So screw you, it's like a message. Let's go take a look at the functionalities and the API calls. So we see internet access over here, and then we see get host by address. So it actually returns like a host profile. So in this case, it's probably a backdoor that we're looking at. We have inet address and inet NTOA socket again. Then we have copy the file, load it, creating a file, and then sleep, terminate the thread, creating the process, writing a file, creating a thread, closing the registry key that they probably have started, creating another key, and so on and so forth. And then we see the DLLs over here. So after that, it's all repetition again. But this static analysis have give us an insight on how the malware functions and what type of malware it could possibly be. So for the next video, we will be looking at basic dynamic analysis.